post-liberation agricultural science between colonial legacy and new influences.
In this segment, we will explore how Korean agricultural scientists worked to overcome colonial legacies and establish independent tradition of breeding science, seeking for revolutionary solutions to Korea's persistent food shortage through international scientific networks. Despite organizational restructuring, Japanese influence in the agricultural sciences after liberation still persisted. Key figures in Korean agricultural academia had received their modern agricultural education at Japanese schools, making it challenging for them to be completely independent from Japanese educational and research systems. Furthermore, since only Korea and Japan consumed Japonica rice as a staple food, Korean rice breeders had little choices but to reference Japanese research even after liberation. However, post-liberation South Korean agricultural science did not merely follow existing traditions. Korean agricultural scientists actively sought new knowledge sources such as the United States to incorporate into their research. The trajectory of Cho Baek-hyun, a leading figure in Korean agricultural science, exemplifies this approach. Cho graduated from Kyushu Imperial University's Agricultural Chemistry Department in 1925 and returned to Korea to serve as a Korean professor at Suwon Agricultural College and as a researcher at the Agricultural Experiment Station. When Japanese professors departed after liberation, Cho became the head of Suwon Agricultural College, and when it was incorporated into Seoul National University, he became the dean of the College of Agriculture. To rebuild agricultural education devastated by the Korean War, Cho oversaw post-war reconstruction project led by the United States. He was responsible for rebuilding the Suwon campus with foreign aid funds and managing overseas training for about 40 exchange professors from the College of Agriculture SNU to University of Minnesota, USA. In the 1960s, he conducted joint research with the International Atomic Energy Agency, or IAEA, on using isotopes for tracing fertilizer, which not only contributed to improving Korea's food provisioning, but also represented the first international collaborative research in Korean agricultural science. In 1965, he was appointed as a standing member of the Atomic Energy Commission and established the Radiation Agricultural Research Institute under the Atomic Energy Agency. Cho's activities provide a snapshot of the trajectory of post-war Korean agricultural science. Most agricultural scientists were educated within the Japanese agricultural paradigm, but post-liberation education and research was inevitably aligned with international projects like the US-led post-war reconstruction programs or Atoms for Peace program, as they were virtually the only research funding source for Korean scientists by the late 1960s.
Domestic breeding research in Korea, continuity and new development.
Overcoming post-liberation chaos and Korean War aftermath, the Agricultural Administration began introducing new varieties again from the late 1950s. First, they completed and released varieties developed during the Japanese colonial rule. Some varieties retained names from the colonial period, such as Palgwang, which had its root in the imperialistic slogan of Hakko Ichi-u. Eventually, varieties that completed selection after 1945 and received new names were also released. Varieties completing selection after liberation had names reflecting the times. Notable examples are Jinheung, which means promotion or encouragement, and Jaegon, which means reconstruction, which were popular varieties throughout the 1960s. By the late 1960s, these post-liberation varieties replaced the older ones. Nonetheless, foreign varieties, including those from Japan, were still considered as candidates for future research. This wasn't necessarily because Japanese breeding standards were higher or Japanese varieties were superior. The introduction of foreign varieties occurs in every country to introduce new genes to the domestic gene pool, which usually tend to be rather homogeneous. Promising Japanese varieties that proved well suited to the Korean climate and soil conditions were often introduced to farms after appropriate modifications and selection processes. Two noteworthy Japanese rice varieties introduced to Korea in the 1960s were Akibare and Reimei. Akibare, originally developed in Aichi Prefecture, was introduced in South Korea in 1969. In Japan, since its release in 1966, it was valued for its good taste and moderate resistance to lodging, but its cultivation remained regional compared with premium varieties like Koshikari and Sasanishiki. However, Akibare became unexpectedly popular in South Korea, partially due to its adaptability to cooler climate and Koreans' preference of chewy taste. In following lectures, we will see how Akibare was received as the arch rival of Tongil rice during and after the Green Revolution. Reimei, released in Japan in 1966, was notable as Japan's first semi-dwarf rice variety developed through gamma-ray mutation breeding. Although its reception as a practical variety remained limited in Japan, its semi-dwarf traits made it valuable for breeding programs both in Japan and abroad. South Korean researchers also noticed Reimei as a useful genetic resource for developing new varieties.
The transition from Japanese to domestic varieties.
The significant change in the 1950s was that varieties developed in the Korean peninsula finally emerged prominently. From Namsan 13 in 1932 until the liberation, the Colonial Agricultural Experiment Station completed 15 varieties, including 8 varieties like Senara, whose hybridization began before liberation but was completed afterward. The number of varieties developing in colonial Korea totaled 23. Among these, Palgweng, Paltal, Pungok, and Susong were widely cultivated until the 1960s. In particular, Paltal and Palgweng formed one of the most widely cultivated variety groups, along with Norin No. 6 until the late 1960s. In 1969, among Korea's 22 recommended varieties, 13 were domestically developed and 9 were introduced from Japan, each group covering a similar cultivation area. The 1960s saw active land reclamation and variety improvement as an extension of post-war reconstruction. By the mid-1960s, there were changes in major cultivated varieties. As Ginbos, which was dominant during the late colonial period, and its derivatives notably declined, 3 varieties, Norin No. 6, Palgweng, and Paltal, occupied about half the total cultivation area, followed by Norin No. 29. Norin 6 was the most widely cultivated variety throughout the 1960s, while Norin 29 emerged as a major variety in the mid-1960s. By the late 1960s, Palgweng surpassed Norin 6 to occupy the largest cultivation area. By the late 1960s, domestically developed varieties like Jinheung, Jaegeon, Sinpung, and Hogwang were being promoted. These domestically developed varieties showed improved fertilizer resistance, lodging resistance, and disease resistance compared to previous generations, with yield increasing by 50 to 77% over native varieties. Among domestically developed varieties, Relatively older ones like Paltal, Phungok, Susong, and Nongguang gradually lost cultivation area, while younger varieties whose hybridization began after liberation, such as Jinheung and Jaegeon, began filling their places. With continued variety improvements, yield steadily increased, with Palgum, which was developed in 1967, being the first to exceed 400 kilograms per 10 acres.
Achievements and challenges ahead.
As in the colonial period, increasing yield remained the consistent challenge for Korean rice breeding after liberation. Under the same natural environment and labor structure, chemical fertilizers were essential to increase rice production. Hence, the primary breeding challenge during this period was improving fertilizer responsiveness and fertilizer resistance. With increased fertilizer production after the 1961 completion of the Chungju fertilizer factory, demand for varieties with strong fertilizer resistance grew even higher. However, major varieties developed until the 1960s showed minimal responsiveness with increased fertilizer. Varieties like Paltal and Susong had weak fertilizer resistance, potentially reducing yields with excessive fertilization, which may explain their continuously decreasing cultivation areas in the 1960s. Increased fertilization also raised demand for lodging-resistant varieties that wouldn't easily collapse. Compared to the 1910s, the use of nitrogen fertilizer increased nearly five-fold by 1980, when chemical fertilizer became commonplace. Native varieties accustomed to minimal fertilization would grow excessively tall and collapse, which made lodging resistance an important breeding objective since the 1930s. Finding a balance between yield and rice quality remained another major challenge. In general, as yield increases, crop stability and grain quality decreases. While varieties cultivated by the 1960s showed significantly improved yield over previous native varieties, they were generally developed with an emphasis on rice quality. Among widely cultivated varieties, Palgwang, Paltal, and Phungok guaranteed reasonable yields while maintaining good taste. Introduced varieties like Norin 6 and Norin 29 were generally high-yielding with good taste. Meanwhile, Jinheung had a high fertilizer resistance and considerable yield, but received less favorable evaluation for taste. Thus, Korean rice breeding from liberation through the 1960s steadily achieved results based on colonial-era legacies. However, Korea's agricultural situation demanded more than gradual development following tradition. To overcome chronic shortage of rice, a revolutionary innovation was anticipated. Particularly, as Green Revolution became a global buzzword in the 1960s, expectations grew in Korea for miracle varieties that could revolutionize agricultural productivity.
The search for a miracle rice.
However, this problem couldn't be solved within the extended tradition of Japanese breeding. Above all, Japanese agricultural science had never pursued Green Revolution-style programs. Developing high-yielding miracle varieties was not the most important task in post-war Japanese agricultural tradition. Post-war Japanese breeders pursued delicious rice like koshihikari rather than high-yield varieties. They also showed little interest beyond academic curiosity in the Green Revolution, which was taking place at the International Rice Research Institute in the Philippines at the time. while Japan played the teacher of breeding science for South Korea and other Asian countries, Korean scientists realized that they had to instill heterogeneous elements from different traditions of agricultural science. By the 1960s, despite substantial production increases, rice became increasingly scarce as industrialization progressed and the economy expanded. As national income rose, consumption of barley and other grains decreased dramatically while rice demand surged. When rice demand growth outpaced the production increases, the government had no choice but to import rice. The Park Chung-hee government imported an annual average of 330,000 tons of rice in the late 1960s and 520,000 tons in the early 1970s from countries like the United States. Moreover, as U.S. food aid shifted from grants to loans in the late 1960s, Korea faced spending massive foreign exchange to import grain. For the Park regime, committed to economic growth through foreign capital introduction, every bit of foreign exchange needed saving for industrial reinvestment. Consequently, the government launched rice conservation campaigns, forcefully promoted cheaper barley consumption, and implemented various measures to increase domestic rice production. In such circumstances, policymakers inevitably became attracted to terms like miracle rice. As numerous nations across Asia and Africa got newly independent after 1945, global interest in food and population issues increased, with mixed feeling of pessimism and optimism that technological innovation could eventually solve food problems. Consequently, Korean agricultural scientists began seeking something beyond gradual innovation in developing new rice varieties. And unexpectedly, the awaited news came from Southeast Asia.